this video, we will learn how to solve a problem in fluid mechanics, particularly in fundamentals of fluid flow. So we have here this problem. Lily is trying to drench her plants in the backyard using a garden hose that has an unclogged opening with a cross-sectional area of 3.02 times 10 raised to the power of -3 square meter. Before watering the plants, she first filled a bucket with a volume of 9.12 times 10 raised to the power of -3 cubic meter. Determine the time at which Lily can fill up the bucket if the velocity of water leaving the hose is 0.08162 meter per second. So for this problem, we have listed first the given. The cross-sectional area of the garden hose, 3.02 times 10 raised to the power of -3 square meter. The volume of the bucket, which is 9.12 times 10 raised to the power of -3 cubic meter, and the velocity of the water leaving the hose, which is 0.08162 meter per second. So proceeding to our solution, we know that discharge Q is equals to volume over time, since the unit for discharge is cubic meter per second, and we know the value for the volume, which is 9.12 times 10 raised to the power of -3, and we have here this unknown here. And we also know that discharge is also equals to area times velocity. So to find our unknown, the time, we can actually substitute this here for this discharge, and we can plug in all the values that are known, which is the area, 3.02 times 10 raised to the power of -3 square meter, times the velocity, which is 0.08162 meter per second. And we can now actually find the value of the time, and it will look like this. You are going to divide the volume over the product of the area and velocity. So substituting these values in our calculator, we can solve for our time, and it is actually 37 seconds. So the cubic meter here will cancel also for this here, and we will get that the unit for our time is seconds. So we have an answer of 37 seconds.